Hello everyone, welcome back to Kinetic Tutoring. Today we're taking a look at another AP Physics C Mechanics exam question. So let's just get straight into it. A box of mass m is initially at rest, is acted upon by a constant applied force of magnitude Fa as shown in the box figure above. The friction between the box and the horizontal surface can be assumed to be negligible, but the box is subject to a drag force of magnitude kV, where speed v is the speed of the box and k is a positive constant. Express all your answers in terms of the given quantities and fundamental constants as appropriate. The dot below represents the box. Draw and label the forces, not components, that act on the box. Alright guys, so first off we know we have gravity, and that is going to be going downwards. We have our normal force, that's going to be going perpendicular to the plane. Here we have our drag force, kV, and here we have our force Fa, our applied force. Part B asks us to write but do not solve a differential equation that could be used to determine the speed v of the box as a function of time t. Alright guys, so let's just write out our basic force equation. So we have MA is equal to FA minus KV. Here is our force equation for the horizontal forces. And let's get acceleration alone. We'll get A is equal to FA minus KV over M. And in order to make it a differential equation, all you need to do is change A into dv dt, because that's what acceleration is, change in velocity over change in time. And there you go, there you have it. This is our differential equation. Determine the magnitude of the terminal velocity of the box. We know that when we're at terminal velocity, the box is no longer accelerating, so our MA is going to be equal to 0. So FA minus KV is going to be equal to 0, meaning that FA and KV are equal to each other, and the velocity at that point will therefore be FA over K. So that is your terminal velocity. I'm going to rewrite our differential equation. Alright, use the differential equation from part B to derive an equation for the speed v of the box as a function of time t. Alright, so let's integrate this. We'll divide through here. We'll get dv minus fa minus kv is equal to dt over m. Alright, so let's integrate now. Our m is just a constant, so this is just going to be t over m. Our dv, okay, so from here we're going to do a u substitution, where our u is going to be fa minus kv. We know that our applied force is a constant and our k is a constant, so when we derive we get du. That'll be negative k dv. So if we're going to plug in our negative k dv, we're going to get negative 1 over k integral of du over u, which gives you the natural log of u. And that's going to be equal to t over m. So let's write that out. Negative 1 over k natural log of fa minus kv is equal to t over m. And now we just want to find this in terms of velocity. So we'll multiply both sides by -1/k first. ln is equal to -kt/m. And the reason I did not add a c is because here it says assume velocity is 0 at time t equals 0. Sorry guys, let me just plug in my computer really quickly so it doesn't die. There we go. So we have -kt. Oh, sorry, let me rewrite that. I'm missing a couple things. ln fa minus kv is equal to -kt/m, and we're going to put both of these to the power of e. We'll get fa minus kv is equal to e to the power of -kt/m, and from here subtract fa from both sides. -kv is equal to e to the -kt/m minus fa. Divide both sides by k by -k, and you'll get that velocity is equal to fa minus e to the -kt/m, all divided by k. And there you have it. This is e to the power of -kt/m. Sorry, it's not drawn too clearly. So, as we can see, it's asking us to sketch a graph for the velocity. So it starts at rest, and the velocity begins to increase, but after a short time, the speed at the velocity at which the velocity is changing approaches 0. So therefore the velocity reaches a constant value. If we wanted to find out what that is, we could just plug in t is equal to infinity, and then we would get fa over k. So it's approaching fa over k. So there you have it, guys. That's how you would solve this problem. Yeah, that's all I have for you guys today. Hopefully you guys found this video helpful. If you have any further questions, please make sure to leave them in the comments below. Any feedback or support is appreciated, and that's all I have for you. Have a great day, and I'll see you guys next time.